Let me know once I'm live.
Just a second. We are live now, ma'am.
We are live on YouTube also?
Yes.
Okay, give me a second to open the chat on the mobile also. Okay, I guess I'm live. Okay, thank you so much. We can disconnect. Thank you. Hello, everyone. Am I live? I guess I'm clearly visible, audible to you people. Can you write down in the chat box if I'm clearly visible, audible? I will start the session ahead. Can anyone write down in the chat box? Wait a while. Let me see. If everything is good to go, we will start the session ahead. Give me a second. I guess everything is good to go, right? Yes. So I welcome you all for today's session. A very good afternoon to all of you. I am Dr. Priyanka Sachdev here, and today I am here to continue the marathon of microbiology. So I will finish the entire microbiology. Just a second, let me check my pen. Okay. Okay. So can we go ahead? Okay. So today I'm going to cover entire microbiology in just 4 hours. In just 4 hours, I'm going to crush microbiology and compact microbiology in just 4 hours. So I will cover all the areas of the microbiology. Okay. So I will start with the general microbiology, then move on immunology, then bacteriology, virology, parasitology, and mycology. I guess everything is comfortable. The video, audio, the slides, everything is comfortable to you. Okay, yes. So this lecture is specifically dedicated for the FMGE students, but the university exam preparation, MBBS students and NEET PG aspirants can also attend it if they wish. Okay, so I will cover entire microbiology revision in a super fast manner. Okay, so can we start? Just a second, give me a minute. Is there some problem? Okay, so what to do? Can we fix? Give me a minute. Give me a minute. Can I fix? Give me a minute. Just a minute. Hello, everyone. I'm sorry. There was some technical glitch. I'm really sorry. So let's continue. So I was telling you that we are going to cover entire microbiology in just 4 hours. I will be starting with general microbiology. So let's start with general microbiology and move further. So in the general microbiology, there are few important topics which we are going to cover. And the first topic is the staining. Let me ask you a question. Is it necessary to stain bacteria? My question to you, can you see? This is our preparation. This is our bacterial preparation. I mean, this is our specimen. Why not we take it directly on the slide and examine under microscope? Why it is all necessary to stain the bacteria? Does anyone know the answer? Why staining is necessary? Staining is necessary. The answer is that the bacteria are transparent. Can you see this is a bacteria? It is transparent. And the slide on which we examine, it is also transparent. Can human eyes see a transparent bacteria on a transparent background? No. The answer is no. Human eyes cannot see a transparent bacteria on a transparent background. Human eyes cannot see that, because if we want to see that, we need contrast. We need contrast. To provide contrast only, we need staining. So the purpose of staining, you can see what's the purpose of the staining. Purpose of staining is to provide the contrast. You can see because of the lack of contrast, we are doing staining. If you want to see the morphology of bacteria, you have to do the staining. By morphology, I mean the shape, size, color of the bacteria. What if we use directly unstained preparations? The unstained preparations are known as wet preparation. What if we use directly the unstained preparation or the wet preparation? What we can see? We can see the motility. We can see something transparent. Transparent is moving on something transparent background, but we cannot see the morphology. So two questions from here. To see the motility, you have to use unstained preparation. To see the morphology, you have to use the stained preparation. So learn two questions from this page. Got it? Got it? Now let me tell you the 4 staining preparations. There are 4 commonly stains which are used in microbiology. Let me tell you the 4 common stain which we use in microbiology. The simple stain, negative stain, impregnation method, and differential stain. So these are the 4 stains which we commonly use in microbiology. Let me explain one by one, and let me explain you the questions which are commonly asked from this portion. Okay, why simple stain is known as simple stain? Simple stain is known as simple stain because it gives same color to all bacteria. That's why it is known as simple. You can see in the diagram. Can you see all the bacteria are blue in color? You can see they all are same color. That's why they are known as simple stain. So here we are staining the bacteria, but we are not staining the background. It is simple stain. Okay, we are providing the contrast. Okay, learn 2 examples. The 2 examples are methylene blue and basic fustian. These are the 2 examples of simple stain. You can get a question, image-based question, identify the stain. You can get a question on the definition, that which of the following is the definition of simple stain, or a stain which gives same color to all bacteria is known as what? Or else the third question you can get on example. Methylene blue is an example of. Basic fustian is an example of. You can get question like that. So this is about the simple stain. The second stain is the negative stain. What do you mean by negative? Why negative is known as negative? What do you mean by negative? Ulta. What we are doing here? Here we are staining the background, not the bacteria. You can see what we are doing. We are staining the background, but not the bacteria. We are doing opposite of simple. In the simple, we were staining the bacteria, not the background. But here we are staining the background, not the bacteria. You can see. That's why it is known as negative stain. So we are staining the background, but not the structure to be demonstrated. You get very commonly question on this negative stain. See the image. You can see in the image, the background is black. And you can see the bacteria. The bacteria are transparent. The bacteria are transparent. Can you see the bacteria are transparent here? Now learn 2 examples of negative stain. What are the 2 examples? Commonly you get question on them. India ink is the first example and nigrosin is the second example. So learn the 2 examples, India ink and nigrosin. So commonly you get an image-based question here. You can get an image, identify the stain. So a black background with a transparent bacteria which is standing out on a black background, it is negative stain. So second is negative stain. Coming on the third. The third is the impregnation method. What do you mean by impregnation? Listen. Most of the bacteria, there are many bacteria which are very thin. So we cannot see them. If you want to see a thin bacteria, how you can see them? So you have to do a layering over them to make them thick. If you want to convert a thin bacteria into a thick bacteria, if you want to convert a thin bacteria into a thick bacteria, you have to do layering. You have to do layering over it. So impregnation means layering. It is used for thin bacteria like spirochete. So we do the layering with silver, Ag. We do the layering with silver. Okay, so silver is the only example here. That's it. So we use it for thin bacteria and the flagella of the bacteria. So we have studied 3 stains till now. The 4th one I'm going to tell you. What are the 3 stains we have covered? Please, we will revise it quickly. Tell me the definition, tell me the examples. What is simple stain? Simple stain is a stain that gives same color to all bacteria. It is known as simple stain. Negative stain is a stain that is staining the background, but not the structure to be demonstrated. No. So to provide the contrast, we are doing the reverse. Impregnation means layering, layer over layer. That is known as layering. Now tell me the examples of the three. Who will tell me the examples? Write down in the chat box. Come on, fast. So what is simple stain? Tell me the two examples. Methylene blue and basic question. These are the two examples of simple stain. Negative stain, what are the two examples? India ink and Negrosin are the two examples of the negative stain. And impregnation, only one example we have, silver, Ag. And imagine the images of the three. So either the question will be on definition, or the question will be on example, or the question will be on images, right? So let's come on the fourth and the last stain, that is differential stain. Can I start differential stain? The fourth and the last stain, that is differential stain. So what is differential stain? It's opposite of simple. It's just opposite of simple. What is simple? Simple is something which gives same color to all bacteria. Differential gives different color to different bacteria. So the definition of differential, it gives different color to different bacteria. So here we are having three examples. We will study all three. Okay. So what are the three examples we are having it here? So the three examples we are having here, the first one is the Gram stain. The second is the acid-fast stain, Zn stain, and third is Albert. I will let you know all three in detail. You frequently get question from this section. Frequently you get question from this section. Very high yielding area. Okay. So can I give the three examples, the details of the three examples? Huh? So I'm telling you the examples of the differential stain. Gram stain, acid-fast stain, and Albert stain. One by one, we will see the detail of all three. Let's start with Gram stain. Before that, let's have a question on these three till now. We have covered three now. So let's have a question on these three, then we will move on. So here I'm covering the previous year questions also in this section. In 4 hours, we will cover everything in microbiology, including PYQs. Okay, so here is a question in front of you. Okay, I will read it. You tell me the answer in the comment box. What's the definition of a negative stain? Read the 4 options. The 4 options are in front of you. Can you tell me what is the definition of negative stain? The structure to be demonstrated is stained, yes? Or the structure to be demonstrated is not stained. Is it true? Or the background is not stained, or the background and structure both are stained. What is the correct answer? What is the correct answer? Can you tell me what is the correct answer, please? Yes? So what is negative stain? Here, the background is stained, but the structure to be demonstrated is not stained. Now apply this definition in the 4 option, you will get what is the correct answer. Yes, you all are right. Definitely. The correct answer among them is the structure to be demonstrated is not stained. You get the image-based questions also frequently on this section. So that is the thing. Now coming on the fourth and the last stain. Fourth and the last. That is differential stain. So let's start differential stain, which give different color to different bacteria. There are 3 examples. Okay, let's start the Gram stain. What is Gram stain? Now in Gram stain also there are 4 steps. Okay, in acid-fast stain also there are 4 steps. I want you to compare and contrast between the 4 steps of Gram stain and acid-fast stain. So, it will be very easy for you to understand the 2 steps, 2 type of stains. Let's start with Gram stain. The 4 steps of the Gram stain I will tell you, followed by 4 steps of acid-fast stain. On the next page, we will compare and contrast the 2. So let's start with Gram stain. You can see, okay, listen. Never forget the basic rule. The basic rule is that all bacteria are transparent. Can you see a transparent bacteria here? Say yes, it's a transparent bacteria. Can you see a transparent bacteria here? Yes, these 2 are transparent bacteria in front of you. Have a look. Both of them are transparent. Okay. Now the first step, give a primary stain. What's the primary stain? Any violet stain. Maybe it is gentian violet. Maybe it is crystal violet. The point is that it's violet. So if you are giving violet stain to both the bacteria, so this will become violet in color. This will also become violet in color. Both the bacteria become violet. So step number 1, give a violet stain. That is a primary stain. Now step number 2, give a mordant. The mordant here is iodine. You will say, ma'am, what is mordant? I don't know the meaning of the mordant. What is mordant? See, this is a bacteria. You have given primary stain. The primary stain is violet, so the bacteria become violet. Now the primary stain leaks out. It leaks out. It has a tendency to leak out. We do not want that. We do not want that. That's why we are giving iodine. The iodine will go inside, make a complex with the primary stain and prevent it to leak out. That's why iodine is known as mordant. Mordant is something that prevents the leakage of the primary stain. So any stain which prevents the leakage of the primary stain is known as mordant. Okay, so who is mordant here? Iodine is mordant. So here the iodine is mordant. Step number 2. So here violet becomes fixed. It is not leaking out. Here also wallet become fixed. It's not leaking out. You can see till now everything is same. Now step number 3. Here there is a difference. So step number 3, we will give decolorizer. What's the decolorizer here? It can be acetone or it can be alcohol, but it's never acid. It's not acid. Acid, we take acid in acid fasting, but here we don't take acid. We take alcohol or acetone. So these are the bacteria. Listen, these are the bacteria. They have high peptidoglycan content in their cell wall. So that's why peptidoglycan is like a guard. It prevents the entry of decolorizer into the bacteria. So here the decolorizer cannot enter inside this bacteria because peptidoglycan content is very high. That's why they resist decolorizer and they are still valid. They are still valid. But on the contrary, see the other bacteria. See the other bacteria. See these one. So these bacteria have very thin peptidoglycan, hardly any peptidoglycan content in the cell wall. So the guards are absent. So here the decolorizer can easily enter inside them and decolorize them. So they become transparent. So third step is different. On primary stain, both are valid. On mordant, both are valid. But on applying decolorizer, the bacteria which have high peptidoglycan content, they are still valid. But the bacteria which have low peptidoglycan content, they lose the primary stain and they become transparent. Now, the last step, apply the secondary stain. What is the secondary stain or counter stain? Any stain which is red in color. So usually we use carbol fustian or sapronin, the red stain. So these bacteria are already filled with wallet. They don't have space. They are not hungry. They are saturated. They will not accept the secondary stain and they are still wallet till end. On the contrary, see the other bacteria. They are empty. They are hungry. They are unsaturated. They will accept the secondary stain and they will become red in color. So at the end, we are having two bacteria, the wallet and the red. The wallet one are gram positive, you can see. And the red one are gram negative. So we have two types of bacteria, gram positive and gram negative. How many of you got it? How many of you got it? So we have two types of bacteria. People, based on gram staining, what are the two types of bacteria? Say, ma'am, gram positive and gram negative. Can you elaborate what is the basic difference between them? Say, ma'am, the basic difference is the peptidoglycan content in the cell wall. That is the principle. Okay. So gram positive are the bacteria. They have high peptidoglycan content in the cell wall. And gram negative are the bacteria. They have low peptidoglycan content in the cell wall. Since they have high peptidoglycan content in the cell wall, they resist decolorizer. They do not get decolorized and they retain the primary stain and they are valid till end. On the contrary, the one which are gram negative, they are sensitive to decolorizer. They allow decolorizer to enter inside them. So they get decolorized. They become transparent. They lose the primary stain. They accept the secondary stain. And in the end, they are red in color. So you get many questions on this concept. The basic principle is the peptidoglycan content in the cell wall. Give me a thumbs up. Everyone give me a thumbs up. Learn the 4 steps also. You get the question on the sequence of the steps. We will revise in the end. Okay. Now see, come on the next step, acid fast. We have already completed gram. Now let me explain you the same 4 steps of acid fast. In the acid fast, there will be flip-flap, ulta pulti. The primary stain will be secondary and the secondary will be primary. Likewise, let me tell you. So here also we have 4 steps. Okay. But never forget the basics. What are the basics? All bacteria are transparent. Okay, let's start with the basics. Okay, can you see this is a transparent bacteria? Say yes. Can you see this is also transparent bacteria? Say yes. On both sides, you can see a transparent bacteria. Let's give the primary stain. Okay, so this is the primary stain. Here, the primary stain is any stain which is red in color. Here, in gram stain, we were having the primary stain was violet. The secondary was red. Here, the primary is red. Okay, so usually we use carbol fustian. We use carbol fustian. That's a red stain. So this bacteria become red in color. This bacteria also become red in color because both were transparent. Now step 2 is mordant. What was the mordant in gram staining? It was iodine. But here we have heating. Simple heated. Simply heat, it will get fixed. So here red color will get fixed. Here also red color will get fixed. So till now everything is same. Both were transparent. Both become red. Both the red color become fixed. Now there will be a difference. Let me give decolorizer. What's the decolorizer here? Here the decolorizer is the acid. That's why we use acid fasting. Iska naam hi hai acid fasting. Because we are using decolorizer as acid. Which acid? It's sulfuric acid. What's the chemical formula? You have read chemistry in your 7th, 8th standard in school. What is sulfuric acid? It's H2SO4. Learn the concentration also. You get question on the concentration. It's 20% sulfuric acid. What is the sulfuric acid concentration? 20% sulfuric acid. So these are the bacteria which have mycolic acid in the cell wall. Can you see here mycolic acid is present and mycolic acid is like a guard. It prevents the entry of decolorizer. Decolorizer cannot enter here. Decolorizer cannot enter. Since the decolorizer cannot enter, how it can get decolorized? So they are still red in color. Okay. On the contrary, see the other bacteria. They hardly have any mycolic acid in their cell wall. They don't have. They don't have any mycolic acid in their cell wall. So here the mycolic acid is absent in the cell wall. So here the decolorizer can easily enter inside them, decolorize them, so they become transparent. So step number 3 is different. Hello, you can see these are still red in color because they have the guards, mycolic acid, and they become transparent. Now you know the last step. In the last step, we provide a secondary stain. The secondary stain is a counter stain. It is any stain which is blue, not violet. It is blue, like methylene blue. Usually we use methylene blue. So it is any stain which is blue in color. That is methylene blue. Okay. So here, these are the bacteria which are already saturated. They are saturated. They are not hungry. They are filled. They are not empty. So they will not accept. They will not accept the secondary stain. They maintain the red color till end. Okay. But on the contrary, see these one. These are empty. These are hungry. These are unsaturated. They will accept the blue. And in the end, they are blue. So at the end, again, we have two colors. We have two colors, the red and the blue. The red one are known as acid fast and the blue one are known as non-acid fast. How many of you got it? How many of you got it? Here, we don't use the word positive and negative. We use acid fast and non-acid fast. Got it? So at the end, here we have two types of bacteria. What are the two types of bacteria based on acid fast staining, Zn staining? So we have acid fast organism, AFO, and non-acid fast organism, non-AFO. We don't use gram positive and gram negative. Don't use the word positive, negative. The meaning is the same, but the terminologies are different. How many of you got it? How many of you got it? Yes, huh? So AFO are the organisms which have mycolic acid present in their cell wall, and non-AFO are the organisms which have mycolic acid absent in their cell wall. So since they have mycolic acid present in their cell wall, it is like guard. It resists the decolorizer. That's why they maintain the primary stain. They do not take the secondary stain and they are red in color. Okay. On the contrary, the non-AFO are the bacteria. They don't have mycolic acid. That's why they are sensitive. They are sensitive to decolorizer. Okay. They lose the primary because they are sensitive and they accept the secondary because they are hungry. And in the end, they are blue in color. So see the two types. So this is the summary. How many of you got it? So we have completed 2 stains till now. 2 stains. It's in front of you. Can you revise with me? People, please help me now. Please write down in the chat box. Can we revise together? Definitely you are going to get one question. Which question I do not know. Whether the question is on the principle or the steps or any of the sequence, but you are going to get one question on that. It's an ultra important topic. Okay, listen. Let me compare the gram stain with the acid fast stain. Let me compare. Okay, so what is the primary stain here? Here the primary stain is violet, like gentian violet. Here the primary stain is red, like carbol fustian. Let me compare the mordant of both of them. Mordant is something that is fixing the primary stain, preventing it to come out. Here the mordant is the iodine. Okay, it will form the complex inside. And here my mordant is simple heating. That is step number 2. Now compare the decolorizer in both of them. What is the decolorizer in both of them? In gram stain, the decolorizer is either acetone or alcohol. In acid fast stain, it's sulfuric acid. H2SO4. Learn the concentration, it's 20%. I will tell you 3 exceptions here. First, learn 20%. First, learn the standard. I'm going to tell you the exceptions also. Okay. And finally, learn the secondary stain or counter stain in both of them. Learn the secondary stain or counter stain in both of them. So here it is a red stain, like carbol fustian, and here it is blue stain, like methylene blue. At the end, see the colors I have used. I use color very judiciously in my PPT. You can see the colors I have used. Here we have 2 types of bacteria, the violet, the red. The violet are the one which are known as gram positive. The red are the one which are known as gram negative. And here we have 2 colors. What are the 2 colors here? Red and blue. Red and blue. So the red are AFO, acid fast organism, and the blue are non-AFO. So this is the classification. This is the 4 steps we have seen. Now, what is the principle? Don't tell me the principle also. Here the principle is peptidoglycan. Principle is peptidoglycan. Okay, in gram staining. These are the bacteria which have high peptidoglycan, and these are the bacteria which have low peptidoglycan. You get question on that. And here the principle is mycolic acid. These are the bacteria where mycolic acid is present, and these are the bacteria where mycolic acid is absent. Have a look, people. Have a look. Have a look. See the steps. See the classification. See the principle. We are done with two types of stain. The gram stain, the acid fast stain. How many of you got it? How many of you got it? Okay. Do you have any doubt till now? Can we proceed? Okay. Now let me tell you, we are done with the 4 steps. You know the 4 steps here. You know the 4 steps here. Listen, listen. What's the next thing? The next thing I'm going to tell you the classification. Classification of the bacteria based on gram stain and classification of the bacteria based on acid-fast stain. We have a fixed bacteria. First, we will classify them based on the stain, gram stain, and then we will classify them based on the acid-fast stain. Let me tell you the classification based on gram stain. Based on gram stain, we already know we have two types of bacteria. The violet are gram positive. We have already seen that. And the red are gram negative. We have already seen that. This is based on gram stain. The two type of bacteria. Okay, we know. What about the shape? Based on the shape also, we have two type of bacteria. You know, the cocci, the spherical bacteria, the cocci, the spheres are known as cocci. And the elongated bacteria. Can you see these bacteria are elongated one? These one are elongated. The elongated one are known as bacilli. Okay, let me combine the two classifications. Let me combine the two. So we have four types of bacteria. Gram positive cocci, gram negative cocci, gram positive bacilli, gram negative bacilli. So we have four types of bacteria. They are in front of you. This is the basics. This is the basics. Now I want all of you to see the diagram. The four diagrams I have drawn. I want you to appreciate the shape and color in each of them. First, tell me the shape. So here say, ma'am, it's a cocci. So cocci. This one is violet. That's why gram positive cocci. This one is red. So gram negative cocci. This one is elongated bacilli. This one is bacilli. So these two are bacilli. You can see. But this one is violet. That's why gram positive. And this one is red. That's why gram negative. I want you to learn this classification at the tip of your tongue. Okay, the basics. You will get big clinical question, but you will get a clue. There is a gram positive bacilli, gram. So you can rule out or rule in multiple options if you know this classification. Or else you can get image-based question based on the gram staining. Whenever any gram staining image is coming in your exam, whenever any gram staining, you have to see two things in that. Basics, the shape and color. See the shape, see the color. Based on the shape and color, first classify, is it a GPC, GNC, GPB or GNB? Then you will have differentials in your mind looking at the four options, either rule in or rule out. This is the strategy. Got it? We start very from the basic. Got it? Give me a thumbs up, everyone. Are you people live, understanding? Huh? So learn this classification. In the gram-positive cocci, we have only two bacteria, Staphylococcus, Streptococcus. That's it. Only two. Learn the mnemonic. Staphylococcus and Streptococcus. We have only two bacteria. Okay. In gram-negative cocci, again we have only two. The mnemonic is Neisseria and Moraxella, NM. So we have only two, NM. So we have SS, we have NM. Okay. In gram-positive bacilli, we have six bacteria. How many? Six. We have six. Learn the six name. Let me tell you a mnemonic to learn. Can I? So let me tell you a mnemonic. The mnemonic is A, B, C, D, L, M. The mnemonic is A, B, C, D, L, M. A stands for actinomycetes, B for bacillus, C for Clostridia, D for diphtheria, L for Listeria, M for Mycobacteria. So learn A, B, C, D, L, M. I don't prefer you to learn the last category, gram-negative cocci, because remaining all will fall in this category. So accept SS, you leave SS, you leave NM, you leave A, B, C, D, L, M. Inko chhod ke, leaving all these, whatever left is falling in the last category. The last category, that is gram-negative bacilli. Don't learn that. Apart from that, we have few miscellaneous bacteria. Because these are pleomorphic. These are neither cocci nor bacilli. They used to change their shape. That's why we put them in miscellaneous. And they are poorly gram stained. That's why we put them in miscellaneous. So that is Rickettsia, Spirochetes, Chlamydia, and Mycoplasma. So can we revise the class? Okay, we will revise the two together. This is the classification based on gram staining. Now let me tell you the classification based on acid-fast staining also. Okay, after that we will revise the two classifications together. So this is the classification based on gram staining. We divide the bacteria in four categories. Because we are combining the gram stain with the shape. That's why the categories become four. GPC, GNC, GPB, GNB. And you should know the name of the bacteria inside each category. Say yes. Got it. Got it. Now, based on acid-fast staining, we divide them in two categories only. Acid-fast organism and non-acid-fast organism. That's it. We have only two categories. We don't take shape here. We don't take acid-fast cocci, non-acid-fast cocci, acid-fast bacilli, non-acid-fast bacilli. No. We don't consider shapes here. Okay. We take only two categories here. Give me a minute. We have only two categories, that is AFO and non-AFO. Got my point? So here we have only 10 structures. That's it. Learn those 10. Remaining all are here. So don't learn this category. Don't learn this category. Remaining all will fall here. So learn these 10. Among these 10, I'm having a mnemonic. 5 of them are bacteria. Okay. 2 of them are fungus. Okay. 2 of them are parasite, okay, and 1 is miscellaneous. So total 10, 5 bacteria, 2 fungus, 2 parasite, and 1 miscellaneous. Remaining all are non-acid fast. Okay, so this is the total 10 organisms, 10 which are acid fast at the tip of your tongue. If I ask you de novo, tell me acid fast organism, everyone will say ma'am Mycobacterium tuberculosis. Uske aage tum kuch bolte hi nahi ho. At max you will say ma'am Mycobacterium leprosy. Okay, so there are 10. You should know all 10. What are the 5 bacteria? Again, I'm having a mnemonic. What are the 5 bacteria? 5 of them are bacteria, 2 of them are parasite, 2 of them are fungus, and 1 is miscellaneous. Got it? What are the 5 bacteria? The mnemonic is no longer separate booking for MI phone or my phone. No longer separate. No, N stand for nocardia. Longer, S stand for legionella. Separate, S is smegma. Booking is bacterial spores, and MI phone. It's Mycobacterium. Here, Mycobacterium TB as well as leprosy both will occur. Say yes if you got it. No, say, can we see the mnemonic together? Say no longer separate booking for MI phone. So it's nocardia, legionella, smegma bacilli, bacterial spores, and Mycobacterium TB, leprosy, all Mycobacterium. Avium complex, all Mycobacterium. So this is the bacteria. What about the parasites? We are having 2 parasites, both, we are having 3 parasites, I'm sorry. So total 11 you can make. Okay, all of them are sporas. All of them are sporas. Isospora, cyclospora, cryptospora. Spora. All the sporas. Okay, we are having 2 fungus also. All of them are coccus. So it is rhodococcus, cryptococcus. All coccus. And finally, the miscellaneous is human male sperm, the sperm head. So can we revise? Huh? So, okay. So we have studied the gram stain. We have studied the acid fast stain. Okay. The gram stain. Okay. And Zn stain. Zeal-Nelson stain or acid fast stain. You know the 4 steps? Oh, no. You already know the 4 steps. I'm not revising that. Based on the gram stain, what's the classification? And based on acid fast stain, what's the classification? Based on gram stain, we divide the bacteria into 4 categories. What are the 4 categories? Can we revise? So say, ma'am, we combine the gram stain and shape together. So we have gram positive cocci, gram negative cocci. These are the cocci we have completed, only 4 cocci. Gram positive bacilli and gram negative bacilli, the biggest category. And in Zn stain, we have only 2 categories. Acid fast organism, AFO, and non-acid fast organism. I want you to say this last one. It will be ultra useful for you for the, clinical approach based questions. If you know this classification, things are going to be super simple for you. Believe me. Can we revise it together? Huh? So say, gram positive cocci are only 2 in number. Say, SS, strep, that's it, khatam. Okay. Gram negative cocci are again 2 in number. It is Neisseria, Moraxella, khatam. So we are having only 4 cocci in this world. So all 4 are in front of you. Let's come on the bacilli. In the bacilli here, gram positive bacilli are 6 in number. There is a mnemonic. A, B, C, D, L, M. What is the full form? A stand for actinomycetes. B for bacillus. C for Clostridia. D for diphtheria, Corynebacterium diphtheria. L for Listeria. And M for Mycobacterium. Okay, G. And remaining all will fall here. Don't learn. Accept these remaining all will fall here. Okay, so don't learn. Jo bhi bach gaya. It can be Pseudomonas, Burkholderia. It can be Brucella, Bordetella, Enterobacteriaceae, Vibrio. They all will fall here. Got it? Coming on Zn stain. Okay. What are Zn positive? So here we have total 10. Total 10. I will not tell you this category because remaining all will fall here. Except these 10, remaining all will fall here. Except these 10, remaining all will fall here. Got it? So what are these 10 structures? Let's divide them. Out of these 10, 5 are bacteria, 2 are parasites. 3 are parasites, 2 are fungus, and 1 is miscellaneous. So if you're taking 3 parasites, I'll make it 11. Okay. So say it. Can we say it? What are the bacteria? I'm having a mnemonic again. What is a mnemonic? Can you tell me the mnemonic? Yes, there is a mnemonic. No longer separate booking for MI phone. No longer separate booking for MI phone. So it's nocardia, legionella, smegma, bacterial spores, and Mycobacterium. All Mycobacterium, TB, leprosy, avium complex, everything. Okay. The parasites are only 3. All 3, spora. Hai na? Cryptospora, cyclospora, isospora. Spora. What are the fungus? Coccus. All coccus. Rhodococcus, cryptococcus, coccus, and miscellaneous sperm. So this is the classification. Okay, got it? Everyone got it? Now in this classification, I want to elaborate a little bit. I want to elaborate a little bit. Listen, all of them require 20% of H2SO4. What is the decolorizer we use? 20% H2SO4, except 3. You should know the 3 exceptions. You should know the 3 exceptions here on which you get the question. Always remember, examiners love exceptions. They will not ask you the standard thing. They will not ask you what is the standard concentration of H2SO4 we use in Zn strain. It's 20%. They will never ask you that. No, they will ask you the exception. So what are the 3 exceptions? See, this is the classification. Okay, everywhere we use 20% H2SO4, na, except 3 places. So the here Mycobacterium is both, na, TB and leprosy. So the first exception is Mycobacterium leprosy. Here, instead of 20, we require only 5% H2SO4. Instead of 20, we require only 5% H2SO4. Please learn that. You get frequently question on that. So Mycobacterium leprosy require 5%. Mycobacterium TB require 20 only, like everyone else. But leprosy requires 5%. Learn that. Okay, one more exception I'm having. Nocardia. It requires 0.5%, not 5 even. Very less. It's only 0.5%. H2SO4 is required to decolorize, not 20%. And the third exception is all sporas. All the 3 sporas. They require 0.25, 2.5% H2SO4 to decolorize them. Learn the 3 exceptions. Now remaining all, except these, remaining all, whatever left, they require 20%. How many of you got it? So the 3 exceptions are known as modifications. What are they known as? The exceptions are known as modification. Give me a thumbs up. The 3 exceptions. Okay, what are the 3 exceptions? So first exception, Mycobacterium lepra. It requires 5%, not 20. The second is Nocardia. It requires only 0.5, not 20. And third is spora. All the spora. They require 0.25, not 20. How many of you got it? So learn the 3 exceptions. Rather than learning like this, learn them in the classification. It will be useful for you. Give me a thumbs up. Come on. You are understanding, yes or no? Interact. Say yes. Got it? Can we go ahead? So learn the 3 exceptions. Learn the 3 exceptions. These are known as modifications. Modifications in H2SO4. Okay, so we are done. I'm not saying this classification again. We have already seen this classification. Based on Gram staining, these are the 4 categories. You know the bacteria inside each of them. Based on acid-fast, Zn stain or acid-fast stain, these are the categories. You already know the name of the organisms or bacteria inside them. Here we are having 11, and here we are having remaining all. Here we are having 2, 2, 6, and remaining all. So this is the distribution, and I assume you know the names. Say yes if you know it. So we are done with this. Okay, the third stain is Albert stain. By the way, what I'm teaching you right now, let's revise it quickly. I'm teaching you the first topic in microbiology is staining. You cannot study microbiology if you don't know the stains in microbiology. So I started my chapter, my topic, my session today with the staining. So I taught you there are 4 types of stain in microbiology. The first is simple stain, which gives same color to all bacteria. No, I've given you examples also. The second was negative, which stain the background, not the bacteria. The third type is impregnation, in which we are doing the layering with silver. Chandi ki parat lagate hain. And the last one, which I'm teaching you right now, is differential. In the differential, I taught you there are 3 examples in differential. Gram, we are done with that. Acid fast or Zn stain, we are done with that. The third one is the Albert. So after Albert, our staining topic will be completed. Got it? So let's come on the Albert stain. Let's come on the Albert stain. What is Albert stain? Albert stain only 5 bacteria in the world which have metachromatic granules in them. Only 5 bacteria have metachromatic granules. So basically, Albert stain is a stain with stain metachromatic granules. So only 5 bacteria have that. So only 5 bacteria are Albert positive. Rest all are negative. So we divide them in 2 categories: Albert positive, Albert negative. So Albert positive are only 5. The 5 bacteria which have metachromatic granules in them. So what are metachromatic granules? Can you see here the bacteria? Albert stain give green color to the bacteria. Can you see the bacteria is green color? Have a look on the image. On the image, you can see the bacteria is green color. Appreciate. You're not colorblind. You can appreciate the color is green. And it gives blue, dark blue or black color to the metachromatic granules. The metachromatic granules are present at the poles. The metachromatic granules are present at the poles of the bacteria, at the 2 poles of the bacteria. So appreciate the color. The green bacteria with the blue granules. So these are the metachromatic granules. Only 5 bacteria have that. What's the mnemonic? What is the mnemonic? I'm having a mnemonic for that also. So there are 5 bacteria, okay, which are Albert positive, which have metachromatic granules in them. The mnemonic is MHC garden in Agra. Have you ever visited Agra? In the Agra, there is a garden. The garden is MHC garden. Actually, it's not there on the map. For the mnemonic, we have created it. So the mnemonic is MHC garden Agra. Okay, M stand for Mycobacterium, all the mycobacterium. Okay. S stand for spirulum. Okay. C stand for Corynebacterium diphtheria. Garden is Gardnerella and Agra is Agrobacterium tumefaciens. So these are the 5 bacteria which are Albert positive. So finally we are done with the 3 type of stain, 3 type of differential stain which give different color to different bacteria. So first example was Gram stain, second example was Zn stain, and third example is Albert stain. My point is that you should know their steps, you should know their principle. Here the principle is peptidoglycan content in the cell wall. Okay, here the principle is mycolic acid in the cell wall, and here the principle is metachromatic granules. So these are the stains which differentiate the bacteria in two categories based on this. This is the principle. You should know the principle in each of them. And the second thing you should know, the classification. Based on the Gram staining, there are 4 types because we are combining the shape also. So we have Gram positive cocci, Gram negative cocci, Gram positive bacilli, Gram negative bacilli. You know the classification. Here we have only 2. Acid fast organism, non-acid fast organism. And here also we have 2. Albert positive, only 5, which have metachromatic granules, and Albert negative. Remaining all are Albert negative. How many of you got it? I want each and every one of you give me a thumbs up if you got this. Give me a minute. Each and every one of you. Give me a thumbs up. You got it? Everyone got it? Do you have any confusion in that? So this is the stains and microbiology. Got it? Now, after all these things, before ending this topic and coming on the next topic, let me tell you a special stain in the end. Let me tell you one of the special stain in the end, that is bipolar staining. So let me tell you the bipolar staining. What is bipolar staining? Listen, I taught you many types of stain. I taught you simple stain, negative stain, impregnation, Gram, acid fast, Albert. I taught you many. So this is a bacteria. See, this is a bacteria in front of you. Can you see? So whatever stain I'm giving to the bacteria, this is what you are assuming. You are assuming the stain is uniformly distributing throughout the bacteria. You say, ma'am, which stain is it? It can be any stain. It can be simple stain. It can be Gram stain. It can be Zn stain. It can be Albert stain, but it can be any stain. But the point is that it is uniformly distributed inside the bacteria. See, have a look on the diagram. It's uniform everywhere. Okay, but there are 5 exceptions. 5 bacteria are there in which the stain is not uniformly distributed. The stain, you can see the stain is accumulating at the poles. The stain is accumulating at the poles of the bacteria. You can see it's accumulating at the 2 poles. Can you see? This is a pole of the bacteria. This is a pole of the bacteria. So stain is accumulating at the 2 poles. So that's why this is known as bipolar. It's a special stain. It is known as bipolar. Have you seen the structure at your home? Have you seen the structure at your home? What is the structure? It is known as safety pin. I guess everyone have seen it. So it's a multi-purpose pen. You can see this is safety pin. So is the bacteria looking like a safety pin? Yes. You can assume this is the bipolar staining. The stain is accumulating at the 2 poles and the bacteria is looking like a safety pin. That's why the bipolar staining is also known as safety pin appearance. One and the same thing. Either say bipolar, you can see it's the 2 poles, bipolar, North Pole, South Pole, and you can see safety pin. So you say bipolar staining and safety pin is same. It is the 5 bacteria, the 5 exceptions in which the stain accumulate at the 2 poles rather than distributing uniformly like this. So name the 5 bacteria. Name the 5 bacteria. What are the 5 bacteria? You have to name them. Okay. So the 5 bacteria are in front of you. Okay. I'm having again a mnemonic. There are many mnemonics that I must tell you here. So the mnemonic is in front of you. The mnemonic is, okay, let me first read it, then I will show you. Can produce very high yield. Where you use the safety pin at your home? See, ma'am, safety pin is a multi-purpose pin. We use it at multiple places. So can I use the sentence that safety pin is having high yield? So my mnemonic is safety pin can produce very high yield. My mnemonic is safety pin can produce very high yield. Okay. Okay. So by which I can remember that this is the mnemonic for safety pin. Okay. So C stand for Campylobacter granulomatis. P stand for Pseudomonas, but it's not Pseudomonas aeruginosa. Please mind it. It's not Pseudomonas aeruginosa. Main hero nahi hai. It is the side hero. Pseudomonas malai and Pseudomallei. Okay, because in the option you will get aeruginosa also. That's why please write down in the bracket. It's not Pseudomonas aeruginosa. V is Vibrio. Again, it's not Vibrio cholerae. It's not the main hero. Again, the side hero. Vibrio parahemolyticus. Write down not cholerae in the bracket. Okay. H for Haemophilus. You can see. H for Haemophilus. But again, it's not Haemophilus influenzae. Main hero yahan bhi nahi hai. It's the side hero Haemophilus ducrei. And last Y is Yersinia. Here the main hero only. So Yersinia pestis is there. So tell me the mnemonic. Tell me the mnemonic. The mnemonic is can produce very high yield. Who can produce very high yield? Say, ma'am, safety pin. Safety pin can produce very high yield. So let me draw a safety pin for you. So I'm trying to draw a safety pin. So this is the bipolar staining or safety pin appearance. Can produce very high yield, among which these three are side heroes. These are not main bacteria. The side heroes are there. Main heroes are not there. Try to say the full form, people. Try to say the full form. So C is Campylobacter. P is Pseudomonas, but Pseudomonas not aeruginosa, Malaya Pseudomoni. V is Vibrio, but Parahemolyticus, not cholerae. H is Haemophilus, but it is Haemophilus ducrei, not Haemophilus influenza. And Y is Yersinia pestis. So this is how you have to learn. Okay, got it? Do you have any confusion till now? Huh? So is it as Yawson stain? No, Chiranjeev, it is not known as Yawson stain. It is bipolar stain or safety pin appearance. Any other confusion you have? Give me a thumbs up. Everyone give me a thumbs up. So this is the topic we have completed. Can we solve few questions? 1, 2 questions, the previous year questions based on this. We are done with staining, people. Definitely take my words. Whatever exam you are targeting. I know it is specifically for FMGE students, but if you are a NEET PG aspirant also, in both these exams, 1 question is from staining. In microbiology, 1 question is from staining every year. So you have secured 1 question in your pocket if you have concentrated till now. So 1 question counts. Each and every question count. 1 question can take your rank ahead, thousands of ranks ahead. And 1 question wrong can take you thousands of ranks behind. Got it? So each and every question counts. Okay, listen. See the question in front of you. Read the question. Tell me the answer. Read the question and tell me the answer. Arrange the order of gram staining as below. Arrange the order. Can you arrange them in order? I'm asking the order of the gram staining. You know the 4 steps? Huh? Your options are mordant, acetone or alcohol, crystal violet, and carbol fusion. So in gram stain, the first step is violet. So what is violet? The violet is crystal violet. So it is 3. Then we use the mordant, which is iodine. So it is 1. Then we use the decolorizer, which is acetone or alcohol. And finally, we use a red stain. The red stain is carbol fusion. In the similar way, you can get a question on the order of the Zn stain. So arranging them in order is a very frequent question you frequently get in your exams. Got it? Can we go ahead? Yes, you all are right. You all are right. Yes, it is more than sufficient for FMG exam preparation, Janvi. Okay, it is more than sufficient. Whatever I'm teaching you, everything will be from this only. And not everything, but I can challenge most of the thing. 90% hit rate will be from this session. I can challenge. Because the ultra important points we are going to cover in the 4 hours. Okay, concentrate now. Read the next question. Modified Zn stain is used for. The 4 options are, concentrate on the 4 options. Mycobacterium tuberculosis, Legionella, Nocardia, or all of the above. So what I am asking? Huh? What I am asking? Modified Zn stain. Modified Zn stain. Yes? Modified Zn stain. What is the correct answer I am asking? What is the correct answer here? Just a second. The video got paused. What happened? I guess it's working. Okay. Yes. So no. Okay. The question, answer should be B and C. I'm asking modified. No. Answer is not D. If I remove the word modified, then answer is D. But I'm not removing the word modified. I'm maintaining the word modified. Modified Zn stain. Modified. Modification means exceptions. Exceptions हम कहाँ use करते हैं? No longer separate booking for amiphone. So Nocardia and Legionella both are coming. So ideally B and C both are correct. You can see B and C. Okay, I'm sorry. No longer separate booking. The correct answer is Nocardia only. Because I'm asking the modified exceptions. There are only 3 exceptions I told you. Mycobacterium lepra, in which instead of 20% we use 0.5%. Nocardia, in which instead of 20% we use 0.5%. Okay. And the sporas, the 3 sporas, in which we use 0.25%. So इनमें से options में क्या है? They are asking modified. Modified means they are asking the exceptions. So इनमें से option में Nocardia is there. So my answer is Nocardia. Okay, if I remove the word modified, if I ask you all Zn stain, positive organisms, so your answer will be D. But currently answer is C. So one word making a sense. If I remove the word modified in this question, answer will become D. But if I am maintaining the word modified in the question, answer is C. So one word is changing my answer. How many of you got it? Read the next question. Tell me the answer. Quick, fast. All the organisms show bipolar staining except, I'm asking the except. You should know the mnemonic to be applied. What is the mnemonic? Safety pin. Bipolar staining is safety pin. What is the mnemonic? Safety pin can produce very high yield. This is the mnemonic. So say what is not coming in this mnemonic. Campylobacter is coming. Say yes, ma'am, it's coming. Okay. Yersinia pestis is coming. Say yes, ma'am, it's also coming. What about Pseudomonas malayi? Is it coming? Yes, Pseudomonas malayi is also coming. What about the last option? Haemophilus influenzae. Is it coming? Say, ma'am, H is coming, but H is not Haemophilus influenza. It is Haemophilus, but it is Haemophilus ducrei. It's not influenza. So my answer is D. So you should know the full form. Knowing mnemonic is of no use. I say no use, no use. Rather, if you know the mnemonic, you will get confused in the exam. Knowing full form of the mnemonic matters. Okay. Mnemonic to KG का बच्चा भी याद कर लेगा. 2-4 बार सुनाओ तो. तुम्हें full form learn करना है. So please, I am requesting you to learn the full form. Learn the full form here. Okay. So this is the thing. Okay. Now coming on the next topic. Structure of the bacterial cell. Here I want to tell you 3 things. The capsule of the bacteria, flagella, and spores. One by one we will see. So let's start with the capsule. Okay. How many bacteria have capsule? Only 9 bacteria in this world have capsule. You should know the name at the tip of your tongue. I will give you a mnemonic to learn that. Only 9 of them have capsule. Only 12 of them have flagella. 6 plus 6. I will tell you the mnemonic. And only 4 of them have spores. Because you get frequently questions on them. The capsulated bacteria, non-capsulated bacteria, motile organism, non-motile bacteria, spore-forming bacteria, non-spore. So, you know, looking at the options and looking the questions, big clinical questions, you will get is it a clue. Question will be not as simple. Which of the following is a capsulated bacteria, non-capsulated bacteria? No. Question will be not. It will be a big clinical question, but they will give you a clue whether on culture or on gram staining, we found the organism is capsulated. So you will get a clue that they are talking about some capsulated bacteria. So looking at the options, you can either rule in or rule out. So I want you to know the names. Okay, 3 mnemonics. So coming on the capsule. Okay, how many bacteria are capsulated? I told you only 9. 9. Okay, so learn the names. Learn the names. There is a mnemonic. With the help of this mnemonic, we will try to learn the name. Because if you try to learn the list without mnemonic, it will be very difficult for you. Okay, so learn the list with the help of mnemonic. Okay, so let me give you the mnemonic. The mnemonic is, yes, very killer bacteria have pretty nice capsule. So yes ka Y stand for Yersinia. Very ka V stand for Vibrio, but again it's not cholerae. Mind it, it's parahemolyticus. Okay, killer ka K is Klebsiella. There are 2 B. B is double. One is Bordetella, one is Bacillus anthrax. H is Haemophilus influenzae, the main Haemophilus influenzae. P is Pneumococcus. Okay, N is Neisseria meningococci, not gonorrhea. And C is only 2 Clostridia, not all Clostridia, only Perfringens and Butyricum. So you have to be very specific, very specific. Say it once, we will try it together. Ek baar bolo mere saath, it will be easy for you. Say, ma'am, yes, very killer bacteria have pretty nice capsule. B is double. Count, they are 9 in number. Count ek baar fir se. Once again. Say, yes, very killer bacteria. Bacteria is double. Have what? Pretty nice capsule. Now try to say the full form. Y for Yersinia. V for Vibrio, but parahemolyticus, not cholerae. K for Klebsiella. We have double B. One is Bordetella and one is Bacillus anthrax. H is Haemophilus influenzae. P is Pneumococcus, and for Neisseria or meningococci. It's not gonorrhea. And C is Clostridium, but not all Clostridium. It's Perfringens and Butyricum. Now listen, what is the composition of capsule? Capsule is made up of what? Say, ma'am, capsule is made up of carbohydrates, polysaccharide. So all of them, the capsule is made up of polysaccharide except one. Learn the exceptions. Examiner love exception. So except the Bacillus anthrax. In Bacillus anthrax, the capsule is protein in nature. These all are carbohydrate, polysaccharide. Here it's polypeptide. Protein is polypeptide. So learn the exception. It's Bacillus anthrax. In Bacillus anthrax, it's polypeptide. If it is a polypeptide, there may be an amino acid. Na? Name the amino acid. By kaun sa amino acid? Name it specifically. Say, ma'am, it's polyglutamate. Polyglutamate. So you get question on the exception. So first thing, learn they all 9 have capsule. They all 9 have capsule. The second thing, learn the capsule is always made up of polysaccharide. In all of them. I'm sorry. In all of them. Except one. Which one? Bacillus anthrax. Only Bacillus anthrax is the exception you can see in which the capsule is made up of polypeptide, not polysaccharide. And here it is made up of polyglutamate. Say yes if you got it. Say yes. So please learn it. So not all Staph aureus have hyaluronic acid, Charanjeev. Rarely Staph aureus have the capsule. Staph aureus we don't consider it as a capsulated bacteria. Okay. So this is a list of capsulated bacteria. These bacteria always have a capsule. Okay. Now coming on the flagella. Okay. Can you walk? Let me ask a question. Can you walk? Yes, of course. See, I'm walking. We all can walk. We all can walk. I'm walking here and there. Why we can walk? Because we are having the legs. We all have the legs. Okay. God has provided us the legs and that's why we all can walk. Now my next question. Can bacteria walk? Okay. You will say, ma'am, if the bacteria have the legs, bacteria can walk. Who's the leg of the bacteria? The flagella. The flagella is the leg of the bacteria. You can see the flagella in front of you. It is the flagella. So flagella, you can compare the flagella. It is equivalent to the legs of the bacteria. So do all bacteria have the flagella? No, no, no. Only 12 bacteria have the flagella. So can I say flagella is the organ of locomotion? Yes. Is it the organ of motility? Yes. So you can see this is the flagella. You can see it's the organ of locomotion. It is equivalent to legs of the human, and the bacteria which have the flagella, they can move from here and there. So only 12 bacteria have the flagella. Now tell me the types of the flagella. Tell me the types of the flagella. There are two types of flagella. Let me draw it for you. See, this is a bacteria. See, this is a bacteria. Hana, we all have two legs. Hana, humans have two legs. Hana, the distribution is uniform in all of us. But in bacteria, it is not fixed. In some bacteria, the legs are present all around. Multiple legs, multiple flagella. And it is at the periphery, all around. So such a flagella is known as peri. Peri means periphery, peritrichus. Peritrichus flagella, because it is present all around. They are very fast movers. Okay, they have multiple legs. Okay, these are the peritrichus. On the contrary, there are certain bacteria in which the flagella is present at a point, not everywhere. It is one flagella at a point, okay, or multiple flagella coming out, but from one point. It is not all around. See the difference. Here, the multiple flagella are all around. Here, multiple flagella from one point. You can see. Got it? Or the multiple flagella from the 2 points. Like the bipolar. Got my point? These all three are together known as polar. These are known as polar flagella. You can see these three, because the flagella is coming out of the pole. So here, one flagella at one pole, multiple flagella. It is known as a tuft of flagella. From one pole or from the 2 poles it's coming out. So polar is of 3 types. This one is known as monotrichus, one flagella at one pole. This is known as lophotrichus, multiple flagella at one pole. And this one is known as amphitrichus. Amphitrichus means the bipolar arrangement is known as amphitrichus. So polar is of 3 types, but peritrichus, no type, only one type, peritrichus. Polar is of 3 types. How many of you got it? Now I told you how many bacteria have the flagella. There are 12 bacteria which have flagella. How many? 12. Out of the 12, 6 have polar and 6 have peritrichus. So 6 of them are polar, 6 of them are peritrichus. I will give you 2 mnemonics. The 6 here, total 12. Because in your exam, you get specific question. Which of the following bacteria is motile by polar and which of the following bacteria is motile by peritrichus? Now in the polar, don't ask me, ma'am, that among 6, which is mono, which is lopho, which is amphi. That will be too much. But learn at least these 6 are polar. And learn at least these 6 are peritrichus. How many of you got it? You can get an image-based question also, right? Now if you're getting this image, you are getting this image, this image, this image. Have a look on the images. Like you can get a simple image-based question. Okay. So this is the thing, the 2 type of the flagellas. Now learn the 2 mnemonics. 6 of them have polar flagella and 6 of them have peritrichus flagella. So 6 are polar and 6 are peritrichus. So total 6 plus 6, 6 plus 6, total 12 flagellas are there. 12 organisms are there, which is having, okay, 6 plus 6, total 12, I'm sorry, just the 12 bacteria are there which are motile. So let me read the mnemonic for you. So the motile bacteria with polar flagella, the mnemonic is in front of you. Very polar solution HCl. You know, hydrochloric acid is a polar solution. It's a polar. So you will remember कि polar वाला mnemonic है. Polar flagella का mnemonic में polar आता है. So very polar solution HCl. V stand for Vibrio, P stand for Pseudomonas, S stand for spirochetes, H, C, Helicobacter, Campylobacter, I call them bhai. And L is Legionella. It's easy. If you say it's easy. Very polar solution HCl. Very polar solution HCl. Got it? Vibrio, Pseudomonas, spirochetes, Helicobacter, Campylobacter, and Legionella. So you can see, you can read the mnemonic. It's very polar solution HCl. How many of you got it? Now coming on the peritrichus flagella. Peritrichus flagella. Again, I'm having a mnemonic for you. The mnemonic is cute, baby, sleep. SLEP, sleep. Okay. So here C stand for all Clostridia except the main hero. Who's the main hero here? The main hero is Perfringens. So except Perfringens, all Clostridia will come. Okay. B for Bacillus. Okay. All Bacillus will come except the main hero, that is Anthrax. Except Anthrax, all the Bacillus will come. As for Salmonella, all Salmonella will come except Gallorum polorum. So learn the 3 exceptions. Okay. L for Listeria, E for E. coli, P for Proteus. So we will write it once and we will move further. So tell me the 12 organisms which have flagella. Tell me the 12 organisms, 12 bacteria which are motile. 6 of them are motile by polar flagella, and 6 of them are motile by peritracheous flagella. Okay, 6 plus 6. So tell me the full form. Tell me the full form. Tell me the mnemonics first, then the full form. So in polar, the mnemonic is very, polar, solution, HCl. And here the mnemonic cute, okay, baby, okay. I know sleep ki spelling mein double E aata hai, but here we have only one E, C-S-L-E-P, sleep. So I hope you know the full forms. Please learn the full forms. Please learn the exceptions. Here in the first three, we have the exception. Here in the first three, we have the exception. I mean all Clostridia except perfringens. I mean all Bacillus except anthrax. I mean all Salmonella except Gallorum pullorum. So I want you to learn the three exceptions. You get questions on the exceptions. These exceptions are non-motile. Rest all of them are motile. How many of you got it? Give me a thumbs up. Give me a thumbs up. Can we go ahead? Huh? So can we go ahead? Huh? Okay. So these all 12 can walk. See, I walk. See, you walk. We all walk. But the motility of all of us are very different. No? Some of us walk very slowly. Some of us walk very fast. Some of us walk taking the baby step. है ना? कहने का मतलब सबकी चाल अलग-अलग है. Motility is different. Although we all walk, but the motility of all of us is different. Yes, I walk slowly. You walk fast, like that. है ना? So here also all 12 walk. All 12 can move. The 12 in front of you. But the motility is different. Okay, so the important motilities are in front of you. You get the questions on the motility. Okay, so the first is the darting motility. What do you mean by darting? Darting motility is shown by two bacteria. You get very frequently question on that. Vibrio and Campylobacter. You will say, ma'am, what is darting? Hota kya hai darting? Darting matlab shooting star. है ना? हिंदी में कहूँ तो टूटता तारा. देखा है कभी? Have you ever seen? No, I have never seen because it's very fast. You cannot trace it. This one. It's darting. Try to trace the bacteria. You can't. You trace any of them. They are moving like anything. They are shooting star. It is known as darting. It is known as darting motility. It's very fast. It is shown by Vibrio cholerae, and Campylobacter. The darting motility, the shooting star, number one. Number two is tumbling. Tumbling is shown by Listeria. You will say, ma'am, what is tumbling? Tumbling means little bit clockwise, then anti-clockwise. Clockwise, anti-clockwise. This is known as tumbling. See, this one is tumbling. It is shown by Listeria. Trace anyone. It is either clock, anti-clock, clock, anti-clock. This is known as tumbling. Tumbling. Tumbling is shown by Listeria. Okay, that is the second one. Third is corkscrew. Corkscrew is shown by Trypanosoma pallidum. Can you see? It's like a screw. It's like a screw. Trace any one of them. It's corkscrew. It is shown by Trypanosoma, spirochete. And last one is swarming. Swarming. What do you mean by swarming? I call them PT Usha. I call them Milkha Singh. They are very fast runners. They run like anything. So just suppose this is the agar plate. I'm putting the bacteria. They start running here and there. They start running everywhere. Okay. So see, this is the agar plate. Can you see? Here is the agar plate. So I'm putting the bacteria at the center. As soon as I put the bacteria at the center, the bacteria start running here and there, because of which the waves are produced here. The waves is known as swarming. The waves can be circular. It can be in the form of the club shape. The waves is known as swarming. So tell me the bacteria which shows the swarming. So there are three bacteria. Two of them are Proteus. You consider them one only. Proteus mirabilis and vulgaris. Both the Proteus. One is Clostridium tetani. Okay. And one is Bacillus cereus. So three bacteria show swarming. Which three? Proteus. The two Proteus. Mirabilis also. Vulgaris also. Clostridium tetani and Bacillus cereus. Give me a thumbs up if you got it. Everyone say yes if you all got it. Okay, can we go ahead? So this is the type of motility. See, the types of motility. Okay, now can you read the question and tell me? Peritracheous flagella is seen in. Is it Vibrio, Proteus, Campylobacter, or Legionella? What is the mnemonic of peritracheous flagella? Cute baby sleep. What is coming in this mnemonic? I guess everyone knows the answer. Proteus is coming in this mnemonic. P for Proteus. So correct answer is Proteus. So the mnemonics will be highly useful for you. The next thing, how many bacteria are spore forming? Kitne bacteria banate hain spores? How many bacteria form spores? Spores is the resistant stage. Only 4. 4 bacteria form the spore. The mnemonic is BSc chemistry. Okay. So B stand for Bacillus anthrax. Okay. S stand for Sporosarcina. Naam mein ye spore. It's a rare bacteria. The 2C, Clostridium and Coxella. Clostridium coxella. So you can see the spores. They form the spores, bulging or non-bulging. Some of them form bulging, some of them form non-bulging, but they form the spores. How many of you got it? The spore forming bacteria. The next thing, what is generation time? How does bacteria divide? See, one bacteria is coming, dividing into 2 daughter bacilli. Can you see the one bacteria? It's coming and dividing into 2 daughter bacilli. This is known as binary fission. Appreciate the binary fission. The time required by one bacteria to convert into two daughter cells is known as binary fission. It's known as binary fission. So this is the generation time. This time is known as generation time. The time required by one bacteria to divide into two daughter cells. Okay, generation time. Usually it is 20 minutes. Every 20-minute bacteria divide from 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, 64, so on. It's never ending. Okay, every 20 minutes, normally. Now, based on this, I would like to tell you the bacterial growth curve. Let me tell you the bacterial growth curve. Can I tell you bacterial growth curve? Let's start bacterial growth curve. Listen, this is a culture media. In this culture media, you have inoculated bacteria. For example, I have inoculated 3 bacteria. For example, I have inoculated 3 bacteria. You can see I have inoculated 3 bacteria. This is inoculation. What I'm doing here, I'm providing everything to the bacteria. I'm providing food, water. So bacteria, every 20 minutes they divide. They should divide from 3 to 6, 6 to, they keep on dividing like that. But for the next few minutes or few hours, they don't divide. They are still 3. So this is known as lag. आप कहते हो ना मैम lag आ रहा है. Lag मतलब क्या? Delay. What is lag? Lag means delay. So they are not dividing. You say, why they are not dividing? They are getting food, water, temperature, pH, everything. Why they are not dividing? They are adjusting in the new environment. Whenever we go to a new place, we just adjust for the few minutes, for the few hours. Then we get used to. So in the same way also, bacteria is adjusting in the new environment. It is the adjustment. And it is doing the preparation for cell division. I call it a preparatory phase or adjusting phase. The bacteria is adjusting in preparation for the cell division. Bacteria eat, become obese. You can see the size of the bacteria is increasing, but not number. So in the lag, the size increase, but not number. Size is maximum, but not number. You can see it's still same. It's same. Mark on the graph. After that, bacteria divide like anything. You can see from 2 to 4, 4 to 8, 8 to 16, 32, 64. They keep on dividing. It is known as exponential growth. What is exponential growth? Have you read logarithm in your childhood in mathematics? It is known as logarithm. That is log. This is known as log. Log matlab logarithm. Logarithm means exponential growth. So here the number become maximum, but size again reduce. So in lag, the size is maximum, but number same. Here the number is maximum, but size same. So lag, log. Lag matlab delay in cell division, and log means logarithm. How many of you got it? After that, it's a culture media. Now in this culture media, the food, the nutrition get exhausted. Started exhausting, not completely exhausted. So the bacteria which get the food, they are fighting who will get the food. The bacteria which get the food, they divide. The bacteria which do not get the food, they die. So number become constant. The bacteria which are dividing the same number, they are dying. So the number become again constant. It's known as stationary phase, also known as P2 phase. So here, whatever number they are formed, the same number they are destroyed. Whatever number they are formed, the same number destroyed. So formation is equal to destruction. So that is stationary or P2 phase. Finally, the complete nutrition get exhausted. Complete. They all will die. It's known as decline phase. So on this graph, the first thing they can ask you the labeling. So learn the 4 phases. First is lag, then log, then stationary or P2, and finally decline. And learn one unique property. Okay. In the lag, learn size is maximum. You get question on that. In the log, the number is maximum. You get question on that. Rather, the number is maximum on the end of the log, not at the beginning, the end of the log. In the stationary, number is same because whatever form, the same number get destroyed. Now here there is an unfavorable condition. The stationary phase. You see the food get exhausted. The food started exhausting. It's an unfavorable condition. So during unfavorable condition, bacteria form spores. So sporulation takes place because it's an unfavorable condition. Sporulation takes place and exotoxin formation takes place. Bacteria form exotoxin and spore in this phase. You get question on that. And finally, in decline, the bacteria are dying. That's why involutionary forms. Here the bacteria have involutionary forms. Say yes. So it is involutionary form. So learn the 4 properties. So in lag phase, you can see lag, the size is maximum. In log, the number is maximum. In stationary, sporulation and exotoxin. And in phase of decline, it's the involutionary forms. How many of you got it? Involutionary forms are there in the decline phase. Say yes if you got it. Everyone say yes if you got it. The next thing, based on the oxygen requirement, how many type of bacteria are there? Based on oxygen requirement, 5 type of bacteria. Based on oxygen requirement. Some of them are obligate, some of them are facultative. What do you mean by obligate? Obligate means strict. कुछ लोग होते हैं ना बहुत strict, है ना? And some, the facultative one are adjusted. They just adjust like us. They adjust in all situations. Okay, listen. Obligate aerobes are the bacteria. They grow only in presence of oxygen. If you don't give them oxygen, they will die. सीधे मरने की धमकी कि oxygen दो तो हम करेंगे divide वरना हम मर जाएंगे. So these are obligate. They are very strict in nature. Got it? Obligate anaerobe. Similarly, Okay, they grow in absence of oxygen. If you give them oxygen, they will die. ये भी सीधे मरने की धमकी कि हम absence में grow करेंगे, अगर oxygen दोगे तो मर जाएंगे. So obligate are strict in nature. Okay, facultative one are the adjustive, like us. Hana, they are adjustive. It doesn't mean they don't have any preference. They also have the preference, but उनकी preference का काम नहीं हुआ तो मरेंगे नहीं. They will adjust. In the opposite environment also they will adjust. So basically, facultative anaerobes, they like to be aerobes, but anaerobically they adjust. Okay, and facultative aerobes are actually anaerobes. They like to be. उनको अंदर से तो anaerobe होना अच्छा लगता है. So they are opposites. है ना? Anaerobes, they like to be aerobes, and aerobes, they like to be anaerobes. But opposite environment, they adjust. They adjust. They don't die. And microaerophilic, they require only 5% oxygen. They require only 5 to 10% oxygen, not much. That is micro. So, you know, maximum दुनिया तो adjust ही करती है हमारे जैसे, है ना? So this is adjusted. Don't learn the list. It's a big list. I do not want you to learn. I want you to learn the ideal one, है ना? The disciplined one, the strict one. I want you to learn the name of the obligate aerobes, है ना? They are 4 in number. You should know their names. And obligate anaerobe, they are 3 in number. है ना? They are very rare. You have to learn their names. And I want you to learn the microaerophilic. So I want you to learn the 3 list. Okay, what are the 3 lists, people? कौन सी है 3 list? Say yes. Say yes. What are the 3 lists? People say, है ना? Obligate anaerobe, obligate aerobe, and microaerophilic. Don't learn the facultative one. Obligate anaerobe, the mnemonic can't breathe air, because if they breathe air, they will die. है ना? Mnemonic is correlating. ठीक है? Can't breathe air. So C stand for Clostridium, B stand for bacterioids, and A stand for actinomycetes. So can't breathe air. Okay. Obligate aerobes, the mnemonic is nasty pest must breathe. What is nasty? It's notorious. They're very notorious. Okay. They must breathe, otherwise they will die. So N stand for nocardia, P stand for Pseudomonas, M stand for Mycobacterium tuberculosis, and B for Bacillus anthrax. And microaerophilic, I'm having a mnemonic. They require only 5% oxygen, not much. So the mnemonic is HEL. Campus boring. HEL stand for Helicobacter, Camp for Campylobacter, bhai. They come together. Okay. Helicobacter, Campylobacter, and B is boring, is Borrelia. How many of you got it? How many of you got it? So please learn the 3 mnemonics. Let's do a question and then we will take a break. Listen. Spore forming anaerobic gram-positive bacilli. The question is looking very simple, but it's chota packet bada dhamaka. Question is difficult. Okay. I want a bacteria among the 4 options which form spores, which are anaerobic, as well as which are gram-positive bacilli. Tell me, among the 4 which are, tell me the 3 mnemonics and tell me a common bacteria among them. What are spore-forming bacteria? Tell me the mnemonic. The spore-forming bacteria is BSc chemistry. It's written in front of you. It's BSc chemistry. What are gram-positive bacilli? A, B, C, D, L, M. At the beginning only I told you the mnemonic. It's A, B, C, D, L, M. Gram-positive bacilli. So gram-positive bacilli is A, B, C, D, L, M. Okay. And you can see here spore-forming is BSc chemistry and anaerobic is can't breathe air or CBA or ABC. Okay. Tell me a common thing in the 3. Tell me a common thing in the 3. If you know the full forms, you can easily pick up what is common among the 3. So common among the 3 is Clostridia, Clostridia, Clostridia. So my answer is Clostridia. So this is a way you should approach. Question is looking super simple, but it's super difficult. If you know the 3 mnemonics, you cannot. If you don't know any of them, you cannot solve this question. Let me change one word in the question, answer will change. Hana? Instead of anaerobic, if I'm saying aerobic, Hana? Still I want a bacteria which forms spore. Still, I want a bacteria. Okay. Let's take a break. After the break, we will continue. I guess it's not live right now. Let's take a small break. Okay.